Yeah, good evening, children. Good evening, Hasini and Sahasra.
Good evening, ma'am.
Good evening, ma'am.
Good evening. I've shared my screen. Visible?
Yes, ma'am.
Yes, ma'am.
Very good. Okay. So I think about 4 to 5 classes earlier, we started this chapter mensuration. And I only can recall explaining the formula related to a cylindrical shell. Did we do cube and cuboid children, online children? Did we understand the formula related to cube and cuboid? Or we did only cylinder and cylindrical shell? I remember explaining cylindrical shell.
Ma'am, I think you did cylindrical.
Hmm?
I think you only did cylindrical. I don't remember that.
Yeah, correct. Okay, fine. So we'll understand all the formulae related to cube and cuboid also today. And then proceed with the chapter. Yeah. I remember I promised something else in the last class. We'll not discuss that and spend time. I'll do the needful. Don't worry. Everything is in my mind. Right. Now, volume of a cube. All right. Now, how do we visualize a cube? Now, imagine you have many paper cutouts, okay, paper cutouts of squares, okay. So you have many paper cutouts of identical squares, say each of side 5 centimeters. What do you have? You have many identical paper cutouts of squares. In simple words, identical squares, say of side 5 centimeters. And you stack them to a height of 5 centimeters. You stack these papers, these square shaped papers, to a height of 5 centimeters. So then you get a solid figure. You get a solid figure, and that solid figure is a cube because its length is equal to the breadth is equal to the height. What are the dimensions of the square? 5 by 5. And now what's the height of the square? You have stacked up the papers to a height of 5 centimeters, right? You have stacked the papers to a height of 5 centimeters. So because the length is equal to the breadth is equal to the height, which in this case is 5 centimeters, the solid obtained is a cube. And you all know a cube has 6 identical square faces. A cube has 6 identical square faces. What's the area of one face? A square, because it's a square. It's a square. Each face of a cube is a square. So what's the area of a square? We all know A square, side into side, or A square. So what will be the area of 2 faces? 2A square. 3 faces? 3A square. 4 faces? 4A square. 5 faces? 5A square. 6 faces? 6A square. No 7 faces. Okay, because it has only 6 faces. So the total surface area, like when you rub your hand all over the faces of a cube. Okay, so you have this Rubik's cube with you, and you just feel it. It's smooth, so you feel it all over. You rub your hand all over the surfaces, 6 surfaces of the cube. So that is the total surface area, the outer area, the total surface area of the cube, which is given by the formula 6A square. Why 6A square? Because A square added to itself 6 times, 6 faces, so 6A square. So how many vertical faces does it have? 4 vertical faces. How many vertical faces does a cube have? Vertical. 6. Like if you imagine a cubicle room, in a cubicle room, the 4 walls are the vertical faces. This is a cuboidal room. Okay. Now, in a cubicle room, okay, in a cubicle room, the 4 walls make the 4 vertical standing faces. Which so these 4 faces are called these 4 faces make the lateral surface. Lateral surface. These 4 surfaces make the lateral surface. the standing surfaces, the vertical surfaces. So in a cubical room, the four walls are the vertical or the standing surfaces. So the four walls of a cubical room make the lateral surface area of a cube or of this cubical room. Now, when you include the area of the ceiling and the area of the floor, right? Lateral surface area of a cubical room is the area of the four walls. The total surface area of a cubical room is the area of the four walls plus the area of the ceiling plus the area of the floor. So total surface area is the area of all the six faces. So in the case of a room, it is the area of the four walls plus the area of the ceiling plus the area of the floor. Same room, cubicle room, area of the four walls alone is the lateral surface area of the room. So the lateral surface area, sometimes called the curved surface area. We say curved surface area in the case of a cylinder, curved surface area in the case of a cylinder. But again, sometimes we do say curved surface area for a cuboid and a cube also. So yeah. So LSA is lateral surface area. CSA is curved surface area. Both mean the same. Curved surface area or lateral surface area both mean the same. Is area of the four vertical faces. So now you understand this. And now in the case of a cubicle room, we don't paint the floor, right? Do we paint the floor? No. The floor is tiled. The floor is tiled. Or maybe something like this is done, but it's not painted. The floor is not painted. Like what you do with the walls, you don't do the same with the floor, right? So if you have to find the area of five faces is in the case of a room, a cubical room, where you want to paint the four walls and the ceiling. The ceiling is painted or it's distempered. Okay, it's distempered or it's painted. So which surfaces or how many surfaces of a cubical room are painted or distempered, whitewashed? Okay, you would have heard these terms, right? Whitewashing, distempering, painting. So only five faces, the four walls and the ceiling. The four walls and the ceiling can be distempered or painted or whitewashed. So that's when we have to find the area of five faces, because four walls and the ceiling, five faces. So it's 4a square plus a square, 5a square.
So one side is A.
Yeah. The total surface area is the area of all the six faces, which is the curved surface area plus the area of the base plus the area of the top, which is 6a square. Now, how else do we understand the curved surface area? We'll also see volume. Now, how did we imagine a cube? We said if we stack identical square, cutouts, paper cutouts. Yeah, you stack them up to the same height as the length and the breadth of the square. The solid obtained is a cube, correct? So we say that the area of the cross section of a cube is a square. When you cut, or when you see the cube, I have the objects in my house. I didn't get it down here. So when you view, one side of the cube, what do you see? You see a square, right? When you just view one side of the cube, what you see is a square. So that's what is a cross section. A cube has a uniform cross section because you can stack identical squares and make a cube, which means it has a uniform cross section. Like a cone does not have a uniform cross section. A cone. You cannot stack circles and get a cone because the sizes of the circles should keep reducing. Only then you'll get a cone. When you have many circles of decreasing radius, you have many circles of decreasing radius. Uniformly, they should decrease. Okay, so then only you can get a cone. So it doesn't have a uniform cross section. The cross section is a circle, but it's not a uniform cross section for a cone. But for a cylinder, the uniform cross section is a circle. Correct? You can stack circles to any height. If you have identical circles, and you stack them to any height, the solid obtained is a cylinder. So the uniform cross section of a cylinder is a circle. The uniform cross section of a cube is a square. Square is a plane figure. Cube is a square is a 2D figure, right? Two-dimensional. It has only length and breadth. Solids are 3Ds. They have 3 dimensions. They need space. Okay. All right. So the uniform cross section of this solid cube is a plane figure, which is a square. 3D is a 2D. Okay. Okay. So now, how do you understand volume? Volume is always area of the uniform cross section into height. Volume is area of the uniform cross section into height. Now, what's the area of, what is the cross section? Square. What's the area of the square? A square. What's the height now of the cube? A. So then what's volume? Area A square into height A, which is A square into A, which is A cube. Just a minute. So volume is area of uniform cross section into height. Cross section is a square. A square into A, which is A cube cubic units. And the curved surface area or the lateral surface area can be expressed as the area of the 4 vertical faces. It means the area of the 4 vertical faces, which is expressed as the perimeter of the uniform cross section into height. What is CSA? It's the area of the 4 vertical faces. That's how we understand curved surface area or lateral surface area. It's the area of the 4 vertical faces. Now, how do we express this area of 4 vertical faces? It's the perimeter of the uniform cross section into height. Area of the uniform cross section into height is volume. Perimeter of the uniform cross section into height is lateral surface area or curved surface area. So what's the perimeter of a square? 4A. A plus A plus A plus A, 4A. Into height A, so 4A square. Is the other way of understanding
4 into 8.
LSA or CSA. One way of understanding is like this. See, you can see an OR here. These are 2 different ways of understanding the curved surface area or the lateral surface area. I'll tell you again. So CSA or LSA is the area of the 4 vertical faces. 4 vertical faces, yes. So one way of understanding is curved surface area or lateral surface area is the perimeter into height. Perimeter of what? Square. Why square? Because that's the cross section. So perimeter of square is 4A into height A. So 4A square. This is one way of understanding. Or CSA or LSA is, again, it's the area of the 4 vertical faces. What's the area of one face? A square. So 4 faces, 4A square. Volume is area of the uniform cross section into height. Area is A square into A cube. That's about the formula. And something more is the length of the diagonal and length of all the edges of a cube. The length of the diagonal of a cube, okay, which is also the length of the longest rod that can be placed in a cubical room. The length of the longest rod that can be placed in a cubical room. So it's the line segment that connects one top corner to the opposite bottom corner. All if you see in your room. So you just imagine the room in which you're sitting is a cubical room. Okay. The length of the longest rod that can be placed in the room or the length of the diagonal. All the diagonals will have the same length. Okay. The length of the diagonal or the length of the longest rod that can be placed in a cubical room is the line segment that connects any top corner to its opposite, not opposite bottom corner. That's the length of the longest rod that can be placed in a cubical room, which is given by, yeah. So the length of the diagonal is given by the formula √3 A units. So this is just Pythagoras theorem. We'll do it when we take up questions. So how we get this formula? Just root Pythagoras theorem. You can see a right triangle here. This is A. This is root 2A because the length of the diagonal of a square is root 2A. Length of the diagonal of a square is root 2A. This is A. When you apply Pythagoras theorem, the length of the diagonal will be root 3A. This is the right triangle. This is the right triangle. So you can see one top corner to the opposite bottom corner is a diagonal. So this is what the diagonal of the square, which is root 2A. This is the edge of the cube, which is A. And when you apply Pythagoras theorem, you will get root 3A as the length of the diagonal of the cube. Of the square is root 2A. Of the cube is root 3A. Now, how many edges does a cube have? A cube or a cuboid? Okay. They have 12 edges. Just get a book. 1 second. Yeah. So here I have a book. It's not a cube. It's a cuboid. It's not a cube. So now let's see the edges. Okay. Edges. Okay. So this is one edge. 1, 2. Similarly behind 3, 4. Correct? 1, 2. Behind 3, 4. Then 5, 6. This side. This is, say, my right side. This is the left side. This is front, back, right, left, top, bottom. All right. Top, bottom, front, back, right, left. So front, 1, 2 edges. Okay, this also will come. We'll take the horizontal ones first. 1, 2. Similarly, behind 3, 4. Okay, then 5, 6. Behind 7, 8. Then this side 9, 10, 11, 12. 1, 2. Behind 3, 4. Side 5, 6, 7, 8, 9, 10, 11, and 12. So it has 4 edges along the length, 4 edges along the breadth, and 4 edges along the height. 4 along the length, 1, 2, behind 3, 4 along the length, 4 along the breadth. This is the breadth, right? 1, 2, and this side 3, 4 along the breadth, and 4 along the height. 1, 2, this one, and behind 3 and 4. So it has 4 edges along the length, 4 edges along the breadth, and 4 edges along the height. So 4 plus 4 plus 4, 12. And the length of each edge is A because it's a cube. It's a cube. So the length of each edge is A. So A 12 times. A plus A plus A 12 times is 12A. So the length of all the edges of a cube is given by the formula 12A. Now, why should you remember this? Supposing you have a gift, you've wrapped it and you want to fasten the edges with a sellotape or maybe some decorative lace. Okay, you've got a gift for your friend. You've packed it. You want it to look more beautiful, so you want to decorate it. Okay, the gift inside is very beautiful. So you packed it. It's nice. You want to make it look more nice. So you have a lace and you want to stick the lace along the edges of the cube. Okay, you want to stick the lace along the edges of the cube. So how many edges? 12 edges. What's the length of each edge? A. So what will be the total length of all the edges? A plus A plus A 12 times, so 12A. So 12A is the length of all the edges of a cube. So if the edge of the cube is say 6 centimeters, the length of the tape you have to buy is 12 into 6, 72 centimeters of tape or lace, whatever. Okay, is what you have to buy. If the length of one edge of the cube is 6 centimeters, then the total length of the decorative lace you have to buy will be 12 into 6, 72 centimeters. So volume A cubed, lateral surface area 4A square, area of 5 faces, lateral surface area is 4 faces, 4A square, 5 faces, 5A square, 6 faces is the total surface area 6A square. Length of the diagonal root 3A, length of all the edges 12A. Cuboid, cross section is a rectangle, meaning many identical rectangles. If you stack many identical rectangles to any height, because it's a cuboid, right? It's going to be a cuboid, right? So no restrictions. So you have many identical rectangles, you stack them up to any height. The solid obtained is a cuboid. You have many identical rectangles, you stack them up to any height. Rectangle is a 2D. When you stack up these to any height, you obtain a solid, which is a 3D. And that's a cuboid. So the uniform cross section of a cuboid is a rectangle. Plane figure, rectangle. Okay, so volume is area of the uniform cross section into height. So cross section is a rectangle. Cross section of a cuboid is a rectangle. Area of the rectangle L into B. Height is H. So LBH is the formula to find the volume of a cuboid. Lateral surface area is the area of the 4 vertical faces. So you can think of a cuboidal room. Normally, rooms are cuboidal, mostly. So the 4 walls. Lateral surface area is the area of the 4 walls. And how do we understand this? It's a perimeter of the cross section into height. Volume is area of the cross section into height. Lateral surface area is perimeter of the cross section into height. And what's the perimeter of a rectangle? 2 of L plus B. Perimeter of a rectangle, 2 of L plus B into H, height of the cuboid. So 2 into L plus B into H, or sometimes 2H into L plus B. Both are the same. 2H into L plus B. This is the formula to find the lateral surface area of a cuboid. Now you can also understand lateral surface area by taking the faces separately. Like. Okay, so see this book. I'll just show you this and then, so how do you understand, what's the other way of understanding this formula? It's the area of the 4 vertical faces that we understand. So it's the area of the front face plus the back face plus the left face plus the right face. Not the top face and the bottom face. Because if you include the top and bottom face, then it's a total surface area. Top face and bottom face is only for the total surface area because they are the horizontal faces. Top and bottom, they are the horizontal faces. They are sleeping. They are horizontal. How many faces are vertical, standing? 4. So we are trying to understand the 4 standing or the vertical faces. So the front face here. Not this, okay? This is the front face. Area of the front face plus the area of the back face plus the area of the right face plus the area of the left face. The total area of these 4 faces. The total area of these 4 faces. Front face, back face, right face, left face. Don't include the top and bottom. Top and bottom is only for total surface area. So what's the area of this face? Length into height. This is the height. This is a rectangle. What is this? Length into height. L into H. Similarly, you have a rectangle behind, an identical rectangle behind this. L into H. Then what's the area of this rectangle? This is B, breadth, into height. B into H. This is B. This is B into H. Similarly, this is also B into H. So add all this. L into H plus behind L into H plus here B into H plus here B into H. Correct? Rectangles. Now, how do you find the area of a rectangle? The product of the 2 adjacent faces. Now, if I say L into B, it's confusing, so I won't say that. How do you find the area of a rectangle? It's a product of it's the product of the length of two adjacent edges. This into this. This into this is the area of this rectangle. What is this L? What is this? Not B, H. So L into H. Behind L into H. Here, what is this? This one, this one, this one. B. This is breadth. Breadth into this one, H. B into H. Here also B into H. So front face is L into H, back face is also L into H, left face B into H, right face B into H. So when you add all this, what do you get? LH plus LH is 2 times LH. BH plus BH is 2 times BH. So what's common? We have studied algebra. What's common? 2H is common. 2H is common. Between these two terms, what is common? 2H. 2H is common. So in the bracket, you get L plus B. Correct, factorizing. By taking out the common factor. See, in this formula, it is perimeter into height, so it comes behind. Here, we take out the common factor. Both are the same, I told. Here, because it's perimeter into height, H comes behind, so it is 2 into L plus B into H. But here, we are taking out the common factor, but both are the same. 2H is common in bracket L plus B. So 2, or you can also say 2 into L plus B into H square units. So this is about the lateral surface area of a cuboid. Area of 5 faces, CSA plus area of the base or the area of the top, whatever. 5 faces. 5 faces means the 4 lateral surfaces and the area of the base or the top, whichever. Yeah, because the area of the base and top will be the same, right? L into B. L into B. The area of the top and bottom is the same. The top is L into B. L into B. The top and bottom area is L into B. Okay. So 2 curved surface area or lateral surface area is 2 L plus B into H plus LB. That's it. You don't have to take out common and complicate it. You can just find this one separately, and add both to get the area of the 5 faces. Total surface area, the area of all the 6 faces. That is the curved surface area, the area of the top, and the area of the base. So it is, what is this one? You can see here. This one. Correct? Area of the top and base. This is top, this is base. This is here. CSA. Top face L into B, bottom face L into B. So now what do you see? You have LB 2 times, BH 2 times, LH 2 times. And only 2 is common now. Here 2H was common. Here only 2 is common. So in the bracket you have LB plus BH plus LH. So 2 of LB plus BH plus LH is the formula to find the total surface area of a cuboid. Front face L into H. Back face L into H. Right side B into H. Left side B into H. Top L into B. Bottom front face. What's Sahasra, what's the area of the front face?
LB.
Front face. What is the area of the front face of a cuboid?
I don't know.
Hasini?
Ma'am, base into height.
Front face. This is the front face. Can you see the front face here? This one.
L into B.
This is the front face. This is the front rectangle. What's the area of this rectangle? L into I. L into H. What's the area of the rectangle behind? L into H. L into H. What's the area of the rectangle on the right and left side? On the right side, this one. PH and the back also PH. What's the area of this rectangle? B into H. B into H. What's the area of this rectangle? PH. B into H. What's the area of the top rectangle? L into B. What's the area of the bottom rectangle? L into B. Right? Okay. LH from the top and bottom BH. Top and bottom? BH. Okay, so this is front and back. LH is front and back. BH. Front and back. L into H. The side faces BH. BH. Top and bottom LB. So you can see it happening 2 times. So 2 common, and this is the formula. 2 of LB plus BH plus LH square units. You just take a cuboid and mark length, breadth, and height. You will understand. You can take a notebook and mark L, B, H with a pen, and then you will understand. So length of the diagonal is given by the formula. Length of the diagonal is given by the formula square root of L square plus B square plus H square. Again, by using Pythagoras theorem, I told you we'll do this. When we take up questions to solve, we'll do this. We'll see how this formula, how we come up with this formula. So this is the diagonal of the rectangle, which is given by the formula square root of L square plus B square. This is the diagonal of the rectangle, which is given by the formula square root of L square plus B square. And this is the height of the cuboid. This is the diagonal. When you apply Pythagoras theorem, you will get square root of L square plus B square plus H square as the length of the diagonal of the cuboid. Length of the diagonal of the rectangle is square root of L square plus B square. Cuboid is, put your hand down. Cuboid is root of L square plus B square plus H square. That's the length of the diagonal. Now the length of all the edges. So same, no? Like in a cuboid also has 12 edges, but the edges are all not the same. They need not be the same. One of it at least will be different. Only then it's a cuboid. At least one will be different. If all are the same, then it's a cube. One of it should be different. It can be 5 into 5 into 6 or whatever combination. So it will have 4 edges along the length, 4 edges along the breadth, 4 edges along the height. So it is 4L plus 4B plus 4H. Now in this book, see in this book, this is the length, right? Length. Similarly, behind we have here, length and length. So how many lengths? 4. 4L. The length of these 4 edges is 4L. Now B, breadth. Here, this is one edge. This is one edge. So we have 2 B's. Then here, B and here, B. So how many edges? How many line segments? How many edges meaning how many line segments? 4. 4 along the breadth. 1, 2, 3 and 4. 4 along the breadth. So 4B. B plus B plus B plus B, which is 4B. Then how many edges along the height? 1. Here, like this one. This is the height. 2. And here, turn. 3 and 4. So the length of all the edges of a cuboid is 4L plus 4B plus 4H. So when you take out 4 as a common factor, it is 4 of L plus B plus H. The length of all the edges, the length of all these edges, all these edges, you know, all these edges, the length of all these edges. Is 4 of L plus B plus H units. Its length. Volume is expressed in cubic units. Area is expressed in square units. Length is expressed in simply units. Length. So many meters, so many centimeters. Length is expressed like perimeter. Length is expressed in units. Area in square units. Volume in cubic units. So that's about cuboid. Cylinder, we've already discussed. For those who did not attend the class, I'll share the recording. Yeah, cylinder and cylindrical shell, we've already understood. I'll share the recording. If you've missed the session, please watch the recording. So these are the different formulae we have in mensuration. So you can just learn, like, see, when you see this, I've just mixed them here. So what is this? Length of the diagonal of a cuboid. What is this? Yeah, so that's why it's for that activity. I've just written everything together. All these formulae put together. All these formulae put together is what you have here. So you can just like ask yourself if you're yeah. So this is for that activity. So what is this? Length of all the edges of a cuboid. What is this? Of a
Cuboid.
cube. Cube, not cuboid. Then this one. Length of the diagonal of a cuboid. Correct. So I'll share these images on WhatsApp. Don't get confused as to what this is, or maybe I'll share this in the end. So these are the formulae you need to memorize.
See, they have made given total surface area and that surface area of cubic cuboid. That's only 4 to pillar. So let me check next year.
No, it's a part of it, son. Next year you will not learn cylinder. You will learn only cone, sphere, and hemisphere. The exceed itself is a curriculum. It caters. It does not may not completely cater to the CBSE syllabus. It should be there actually. It should be there. If it is not there, I'm telling you. See, if it's not there, it is a part of the syllabus. Because 9th standard, you will not learn all this. 9th standard, you will learn only cone, sphere, and hemisphere. And all this together in 10th standard. All this in 10th standard. Cube, cuboid, cylinder, cone, hemisphere, sphere, spherical shell, hemispherical shell, all in 10th. Hemispherical shell, no, okay, we'll see that here. Why are we learning for? Applications of mensuration. One second. Hemispherical. So now this coconut. When if you can find a perfectly spherical coconut, okay, that's an example of a hollow sphere or a spherical shell, because it's not a solid sphere. Inside it's empty, but the wall is thick. The wall is thick. See, the difference between a balloon, a spherical balloon, and a spherical coconut is that in the case of a spherical balloon, the wall is thin. It's so thin that you can almost ignore the thickness. In the case of a spherical balloon, spherical balloon, imagine, that's why I'm repeating. Why do I repeat? I know what I'm saying, but I want you to internalize what I'm saying. That's why I'm repeating. So in the case of a spherical balloon, okay, when you consider the cases, these two cases, a spherical balloon and a coconut, a perfectly spherical coconut, the wall of the coconut is thick, while the wall of the spherical balloon is thin. Now, the spherical balloon, you can also call it a hollow sphere, whereas a coconut is not a hollow sphere strictly, it is a spherical shell. When we use the term shell, that means the wall is thick. So if coconut exists in real life, then we do have applications of mensuration, right? Yeah. Oh, see, I forgot. Now I was sending the images, right? So don't get confused with this image. This is just for you to, yeah, you can ask yourself. Yeah. About the formula. We have done these questions, is it? No?
You only have to fill in the question.
No, because I'm online children. As you all told me, I remember starting mensuration with cylinder and cylindrical shell. These we have to do today, right?
Yes, ma'am.
Okay. All right. Yeah, leave some space to write the formula. You saw the images, right? So leave sufficient space to write the formula and then take down this question and answer it. Yeah, quick. Yeah. And children? Completed? Okay. So we know volume is given by area of the base into height, area of the uniform cross section, area of the uniform cross section or area of the base into height. So area of the base is 8. There's a cuboid, right? What's the formula to find the volume of a cuboid? LBH, correct? So L into B is what? Area of the base. Yes or no? Area of its base meaning L into B. Why L into B? See, there's a cuboid. This is a cuboid. This is the base of the cuboid. This is the base of the cuboid. What's the area of the base? L into B. Area of the base is L into B. That's what I've written here. Area of the volume is given by L into B into H, and L into B is area of the base into height is equal to 880. Maybe you can include that here. Volume is L into B into H is equal to 880. And this L into B is area of the base into height is 880. So 88 into H is 880. And yeah, it's 10. So the height of the cuboid is 10 centimeters. So here we have the ratio of the dimensions of a cuboid. Okay. You have the ratio of the dimensions of the cuboid and you're given the volume of the cuboid. You need to find the actual dimensions. Here, only the ratio of the dimensions is given to you. You don't have the dimensions. It's not 8 centimeters, 5 centimeters, and 4 centimeters. The ratio is 8 is to 5 is to 4. So you'll have to find the actual dimensions of the cuboid. We need to take it as x. What is x? All right. So given this information, we'll have to find the dimensions, the actual length, the actual breadth, and the actual height of the cuboid. So you'll have to start like this. Let the length of the cuboid be 8x units. Let the breadth of the cuboid be 5x units. And let the height of the cuboid be 4x units. You can even call it 8a, 5a, 4a. Okay. Yeah. So now what is volume? Volume is equal to 10240. Yeah, thanks, Navneet. Just volume is equal to 10240 and volume is L into B into H is equal to 10240. What is L? 8x. What is B? 5x. What is H? 4x equals this one. 8 5 are 40. 40 into 4 is 160. X into x, x squared into x, x cubed is equal to 10240. And then this will come for division. X cube is equal to, say, like supposing you get 27. X is equal to the cube root of 27. X is equal to 3. This is just for example. Okay, it's just 3. I'm not saying the answer here is 3. So if x is 3, then what is the length? 8 into 3. What's the breadth? 5 into 3. And what's the height? 4 into 3. Complete this. Done? Okay. Completed? Online children?
Yes, ma'am.
Okay. So volume is 10,240. L into B into H is 10,240. 8x into 5x into 4x is 10,240. So x into x cube, sorry, x squared into x is x cube is equal to, I've just brought these numbers for division and then you should cancel. Have you all written 64 or have you simplified? You simplified or no? You should simplify.
I directly put 61.
Okay, so 5 ones are 5, 2s are 10, 0, 5, 4s are 20, 4, 8. 4 ones are 4, 5s are 1, 2. 8 ones are 864 times. You must cancel. After cancelling, you get 64. X cubed is equal to 64. So x is equal to the cube root of 64. X cubed is 64. So x is equal to the cube root of 64. You can include that if you want. X is equal to the cube root of 64. So 4 into 4 into 4. 4 multiplied with itself 3 times will give you 64. So x is 4. Turn off. Huh? All right. Yeah, this question is for you. So here, a similar, oh, here also 8 is to 5 is to 4. Oh, 1 minute. Okay. Now continue here, children. No, we'll not do this one. Continue here. Find the length of the diagonal for this question. Find the dimensions of the cuboid. Also include this. Also find the length of the diagonal of the cuboid. Please work that. Also find the length of the diagonal of the cuboid. Same question. What's the length of the diagonal? Formula, square root of L square plus B square plus H square. Square root of diagonal, length of the diagonal is equal to square root of L square plus B square plus H square.
It's a big number.
Sorry?
Very big number.
So we have learned squares and square roots, right? So 32 into 32 is 1024. 20 squared is 400 and 16 squared is 256 plus 400 plus 256. So you get square root of 1680. You need to find the prime factors. So it's 2 into 2, 2 into 2 into 3 into 5 into 7. And from 2 2's, 1 2 out. From another 2 2's, 1 2 out. 3, 5 and 7, they don't have a pair. So they remain under the square root. So multiply them. 105. 2 to the 4. 4 root 105 centimeters. 4 root 105 centimeters is the length of the diagonal of the cuboid. Yeah, completed. There are 4 2's, right? 2 2's will come out. Anything was going on? We have to They were hesitant. What is it you were thinking?
No, like, then that you wouldn't know the last third step I knew. After that 2 steps I knew. That I laughed at this.
Oh, you wanted to do by yourself without looking at the board, is it? Okay.
Last 2 steps I
All right. Completed, Harini? Online children, done?
Yes, ma'am.
Yeah. I'll just get you started. You will complete it and tell me the dimensions. So we are given that TSA of the cuboid is 3384. TSA is given by the formula 2 of LB plus BH plus LH. PSA is given by 2 of LB plus BH plus LH. You haven't still memorized the formula, so I'm giving it to you. Next class, you should be ready with them. 3384. So 2 into, what is L? 4x. What's B? 5x. Plus, what's B? 5x. What's H? 3x. Plus L? 4x. H? 3x. Is equal to 3384. See, this is L into B. This is B into H. This is L into H. L into B plus B into H plus L into H is equal to 3384. Correct? L into B, I put it in a bracket. Plus B into H in a bracket plus L into H in a bracket. So 2 into, what is 4 into 5? 20. X into X, X squared. Plus 5 into 3, 15. X into X, X squared. Plus 12X squared is equal to 3384. Now continue. You should take down the question, write down till here and then continue. Yeah, you're right. I'll be equal to. Yeah, I should include this. Let L be equal to 4x, B equal to 5x, and H equal to 3x. Yeah, what's the value of x?
6.
6, huh?
Yes.
Okay. So Navneet says the value of x is 6. Let's see. Yeah, the value of x is 6. Yeah, okay, you can, yeah, find the diagonal. Also find the length of the diagonal. What's 24 squared?
506.
30 squared?
900.
18 squared?
324.
And what's your sum?
1,000.
Yeah, now prime factors.
2 into 2 into 2. 3 into 5.
2 into 2 into
3 into 3 into 5. This 2 cube into 3 square.
1 minute, 30, 10. Yeah, correct. Which is?
2 cube into 3 square into 5 square.
We should not do all that. From 2 to bring 1 2 out. Why do you want to write it as 2 cubed, 3 squared and all that? From 2 2's, bring 1 2 out. From 2 3's, bring 1 3 out. And from 2 5's, bring 1 5 out of the square root. Now what remains?
Now 1 2.
Remains under the square root. Now what's the answer? 2 3 is 6, 6 5 is 30. 30 root 2 centimeters. 30 root 2 centimeters. Good. Completed? Right. See the board visit. Online children? Any questions?
No, ma'am.
No, ma'am.
No, ma'am.
All right. Next one. Similar, no? Surface area is given, which means the total surface area is given, and the dimensions are given to be the ratio 4:2:1. Find its length. You are only asked to find the length of the cuboid, not breadth and height. Find its length, meaning find the length of the cuboid. Do it quickly. Surface area means total surface area.
Same order. LVH.
It's always in that order LVH. Shrikant, I want the answer from you.
And me?
Yes, finish it and share your answer.
Oh, okay, ma'am.
Finished? Yeah. What's the length? Oh, I don't understand. 28. Okay. Shrikant? No.
Ma'am,
Yeah, find the length?
no, ma'am, I'm still working on it, ma'am.
Okay, no problem. Okay. This is L into V, 4x into 2x. This is B into H. This is L into H. 2 into L into V plus B into H plus L into H is equal to 1372. So this is 8x squared, 2x squared, 4x squared. When you add 14x squared into 2, 28x squared. So x squared is equal to 1372 divided by 28. So you get x squared is equal to 49 on simplifying. So x is equal to the square root of 49, which is 7. Right? Yeah. Done, children? Completed, Harini? Okay. Okay. Yeah. Completed, yeah. Yeah, we'll do this question. I'm just doing it in a different order. Yeah. Look at this one. I just skipped one question in the middle, but we'll be doing it later. Okay. Yeah. Find the maximum length of a pencil that can be placed in a rectangular box of dimensions 8 centimeters by 6 centimeters by 5 centimeters. You need to find the maximum length of the pencil. So it's the length of the diagonal. Maximum length of the pencil is the length of the diagonal that can be placed in this rectangular box. Correct? What is the maximum length of the pencil that can be placed in this rectangular box? Rectangular box is the cuboid. And which is the longest line segment in the cuboid? Diagonal. So the length of the maximum length of the pencil will be the length of the diagonal. Fine. Listen to the answer. You can make use of the image. Don't blindly copy. Please understand what you're writing. Children, not to get confused, don't say 8x, 6x, and 5x here. This is not ratio. Okay, this is not ratio. Okay, this is 8 centimeters length, 6 centimeters breadth, and 5 centimeters height. Always it will be given in that order, LBH. This is the length, not 8x. 8 centimeters is the length, 6 centimeters is the breadth, 5 centimeters is the height. So put it in this formula. We get square root of 125, which is 5 into 5 into 5. See, 125. You cannot divide by 2. It's not that I want to write it as 5 into 5 into 5. You cannot divide by 2. It's not divisible by 2. It's not divisible by 3. So you have to divide by 5 next, which is 25. Again, 5, 5, 5, 1. So like that, 125 is 5 into 5 into 5. Now from 2 5s, 1 5 out. And 1 5 remains under the square root. But we are given the value of square root of 5. It's 2.24. So 5 into, what's the value of root 5 given? 2.24. So 5 into 2.24, which is 11.2. So the length of the, maximum length of the pencil is 11.2 centimeters. And that too, you cannot keep it straight, like diagonally you should keep it.
That would be like a little bit smaller or bigger, right? Because 2.24 is not the exact square root of it,
Yeah.
but approximately it is.
Yeah. Completed, children?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
This is the next question. Now I want the answer from you. The areas of the 3 adjacent faces of a cuboid. The areas of the 3 adjacent faces. I'll tell you what the adjacent faces are. See, there are 6 faces, but 3 different faces, right? There are 6 faces, but all the 6 faces are not different. We have 3 different faces. See, like if there are 6 children, 2 of them are wearing a red color dress, 2 wearing blue and 2 wearing green. There are 6 colors, but only 3 different colors, right? There's 1 red, 1 blue and 1 green, only 3 different colors. There are 6 children, but only 3 different colors. So like that, there are 6 faces, but only 3 different faces. So this is the front face, top face and the side face. This side face and this side face, they're identical. This front and back, they're identical. Front face and back face, identical. So front face, one face. Right and left, identical. So this is one different face. Top and bottom, they're identical. So the 3 adjacent faces are the front face, the top face, and the right face. Or you can say the back face, the left face, and the bottom face. Whatever. There are 3 different faces. Front, top, right. Front, top, right. Front is what? L into H. L into H. What's the area of the front face? L into H. What's the area of the side face? B into H. B into H. B into H. And the top face? L into B. L into B. L into H. B into H. L into B. These are the 3 different faces or the 3 adjacent faces. The areas of the 3 adjacent faces are 15 square centimeters. So let's say L, the front face. Is what? L into? What's the area of the bottom face? Or area of the right face or side face that we say? area of the side, area of side face, B into H. Let's say that is 20 centimeters square. And area of top face, L into B. So we have LH. Yeah. So when you multiply all these three equations, L into H into B into H into L into B is equal to 15 into 20 into 12. Correct? Multiply the left hand side and the right hand side. L into H into B into H into L into B is equal to 15 into 20 into 12. L square, B square, H square, or L square into B square, L square into B square into H square is equal to 300 into 12, 3,600. Correct? So this is nothing but LBH the whole square is 3,600. So what is LBH? What is LBH? 60. And what is LBH? Volume of the cuboid. What is LBH?
Volume.
It's the volume of the cuboid. Therefore, volume of cuboid is equal to 60 centimeter cube. This is usually for 1 mark, MCQ.
1 mark.
1 mark.
And ICSE or XCSE?
In CBSE. Maybe not for 8th standard. All these will, all this what you learn.
I understand.
Yeah, not an 8th standard maybe. But you can't say no. You can't say.
Not
Yeah, definitely not in games.
nice. And then for a length, this will be 5 marks.
Correct. Yeah.
Not 5. 3 marks.
Last one, 4 mark. Last question they'll give.
I'm telling you about this whole sets of easy paper, but somehow we have a there.
That was because the question was incorrect. They didn't trap you. The question was incorrect.
Protest not cooperate.